Hello everybody, and this is an example of Thursday's homework, which is integration using or with u substitution, and we're going to be doing number 27, and we're going to be doing the indefinite integral. There's no limits of integration, so this is indefinite, of the square root of tangent x times secant squared of x dx. And if you look at the baby blue part in your homework here, your packet, or even on the website, you already know the answer is 2/3 times the tangent of x to the 3/2 power plus c here. So the question is, so we know the answer is this. The question is how do we acquire this without just copying it down? That's what we're going to practice over here. Okay. So because it's a u substitution, if you remember the golden rule with u substitution, let u equal the inside function, right? Function. So it depends what the inside function is, okay? And we just follow the rules. In this case, you have to think and just say, well, we'll have two functions here, basically. Well, technically three. Well, really four. But you have the square root function, you have the tangent function, you have the secant function, and you have the squared function, right? So there's actually a lot of functions going on here, and so it's kind of hard to decipher which one is the inside one. So I'm going to rewrite this so we can kind of get a better idea of what I'm talking about here. So we have the square root of tangent x times secant of x squared here, right? So technically speaking, you have two inside functions. So what you want to be looking for is the function such that when you take the derivative of that inside function, you actually get the one of these other functions here, right? So you can think for a second here. So let's just say I let u be secant x, right? Let me do that real quick. So then if I take the derivative, so du, you remember the trick that we went over, so du is going to be the derivative of secant x is sec tan, sec tan, right? So it's going to be secant x times tangent x times our dx differential, right? If you recall from yesterday's video, all I did was I multiplied both sides by dx here. If you want, you can review that in the previous video. So if you look back at my problem, so let's just say I did that here. So then what I would get then is I would get the integral of the square root of tan x, right, times secant, sorry you can't see, times secant squared, right? So secant, so we're going to call that u squared and then dx here. So now you can see the problem with letting u be secant x. What's the problem with that? Well, I did plug in the u here, but the point of doing this u substitution is to make it easier to solve. And I didn't really do that. Not only that, du is not here, because I need this dx to become du, which means I need a secant tan. And all I have is the square root of tangent. So when you get something like this, where you have this and that's not even there, we've kind of failed here. What this means is our u substitution was incorrect, okay? That means we made an incorrect one. So we're going to go ahead and try the other one now. So we're going to let u be tangent of x on the inside. And as you do these, you will get better, and it's just a matter of practice, just like anything else. So we're going to take the derivative over here. So we're going to get du, right, equals, what is the derivative of tangent? And that is secant squared of x times dx here, right? And then hopefully right now, a light bulb should be going off at your head, and you should be saying, oh, wait a minute, hey, I've seen this before. Yeah, you have, it's right here. Yeah, right? It's directly right there in front of you. It's staring at you in the face. So then what we're going to do is we're going to rewrite this problem with the u and du substituted in. You're going to see it's going to be much easier to integrate, right? So I'm going to rewrite my problem here. So the integral of the square root of tan x times the secant squared of x dx here. And now what I'm going to do is I'm going to say, okay, so what was tangent was just u, right? So I'm going to rewrite this as the integral of the square root of u times secant squared of x dx, and if you notice, that whole thing is just what? That's du, so I'm going to substitute du in here. Why did I do that? Because look how much prettier this looks. It just looks so much more pretty, and it's just beautiful. It makes us happy here. So we can actually integrate this function now pretty easily. So I'm going to rewrite this so I know what exponent it is, and that's, we should all know that's u to the 1/2 du. I'm going to anti-differentiate or integrate here, and the rule is we add 1 and then multiply by the reciprocal. That's going to be the integral of u to the 3 over 2 du. And now, oops, sorry, I messed up here. So once you add 1, you're going to write that exponent on the antiderivative, not on the integral or the antiderivative here. So in other words, once I add that, I've already antidifferentiated. So I need to say it becomes u to the 3 over 2 times the reciprocal of 3 over 2, which is 2 over 3. And now we're just going to put plus c here, right? And you might be tempted to box this in, but this is wrong. Why? Because I wasn't trying to find the integral of all of this with u. Remember, the original problem had all of these x's and other functions here, right? So we need to do a resubstitution, which is simple, right? So when you're done with your answer, don't box it in with the u's. Substitute back in what u was. And what was u? U was tangent, right? It's right, written right here, right? U was tangent. So then we say, so it becomes 2/3 times the tangent of x to the 3 over 2 power plus c. And this is my final answer, and you can see this is what the answer, is what the answer that they had in the book over here.